Question 1. Circle the fraction that is equivalent to 3.875. Now this is a calculator paper, so the easiest way of converting from a decimal to fraction is to type the decimal into your calculator. Now if you're using a Casio calculator, if you type 3.875 and then press equals, it will convert the number into a fraction automatically for you. So the answer would be 31 over 8. Now it's worth considering what you would do if this was on a non-calculator paper, and there's a few things you can do to quickly whittle down which would actually be a valid answer and which would not be. Now if we look at 15 over 8 to begin with, 15 divided by 8 is not even going to be 2 because 8 doesn't even go into 15 twice, so you could say that that would not be correct immediately. 15 divided by 4, that's going to be 3.75, so that would be out. The only two contenders would be 29 over 8 and 31 divided by 8. Now with those two, you might consider using the bus stop method to actually evaluate what they actually are as a decimal. In the end, you'd find that 31 over 8 was the correct answer. Now when you are looking at fractions, particularly if they are fully simplified and they are divided by say 2 or 4 or 8 or 16, etc., you can actually determine how many decimal places the fraction will actually have. If we consider fractions that are divided by 2, 4, 8 or 16, so anything that's a power of 2, a pattern emerges as to the number of decimal places that the fully simplified fraction would have when converted to a decimal. We can see here that if we have a fully simplified fraction that's divided by 2, e.g. 3 over 2, we'd have one decimal place, 1.5. If it's divided by 4, as in 9 over 4, then it has two decimal places, 2.25. If it's divided by 8, it will have three decimal places, as in 7 over 8 equals 0.875. If we divide by 16, we'd have four decimal places, as in 21 over 16 equals 1.3125. Of course, the next one will be divided by 32, which, if it was already fully simplified, it would have five decimal places. So there are certain tricks that you can use to speed up your deductions as to whether a fraction is actually viable in the question. So dividing by 8s, 4s, 2s, 16s, those can be very quickly analysed and you can figure out what it is quite quickly without necessarily having to do any calculation. Question 2. What is 50 as a percentage of 20? Circle your answer. Now a percentage is just a proportion, which means it can be written as a fraction. Because it's a fraction, you need to figure out what must be the numerator and what must be the denominator. Now when you read a percentage instruction question like this one, where it says as a percentage of, what follows as a percentage of will always be the denominator. So 20 follows that statement, which is why 20 is in the denominator here. So it's really 50 over 20 and then multiplied by 100 to convert it to a percentage. So you must always make sure you're looking for that as a percentage of. So if they say as a fraction of something, as a proportion of something, or as a percentage of something, the something, the thing that follows as a percentage, etc., of, must be the denominator. So 50 over 20 times 100 is 250%. Question 3. Circle the point that does not lie on the curve y equals x cubed. Now an equation of a curve or a line is just defining a pair of coordinates, such that if you substitute a value of x into the equation, it will generate a value of y. Now any point that lies on this particular curve must satisfy both the x and y requirements. So when you substitute a value of x in and you cube it, it must generate the correct corresponding value of y. So for each of these four coordinates, what you've actually got to do is check them individually. So start with the first one, which is x equal to negative a half, and substitute it into the formula for y equals x cubed. So x is equal to negative a half, type it in the calculator and cube it. Now because this is a calculator paper, just be careful when you are typing in negative numbers. Now as a general rule, particularly if you're using Casio calculators, write any negative number within a pair of brackets. So you can see here that negative a half has been written in brackets just there. That way you can ensure that the calculator processes the value in the correct way and you won't get the wrong answer. In this case, it wouldn't have actually made too much of a difference, but if you're dealing with even powers, it can become a bit of an issue. Now, when you evaluate negative a half cubed, you get negative an eighth, but you can see here negative eighth was also the corresponding value. So that tells you that that is actually on the curve y equals x cubed. Now we try x equals 5. Well, 5 is just positive, so 5 cubed equals 125, which is the correct pairing as well. That lies on the curve also. Then we try this one, x is equal to a third. Substitute a third in, cube it, and you get a 27th. But they've got here a 9th, so you know that this point already is not going to be the correct point that lies on the curve. For completeness, here's the last one, when x equals negative 1. If you cube negative 1, you would get negative 1, which is the correct pairing here, so that's also on the curve. So this is the correct answer here because it does not lie on the curve of y equals x cubed. It would actually lie on the curve of y equals x squared, because if you square a third, you would get a 9th. So just to recap, y equals x cubed looks like this red line here. It's a standard graph, and you do need to be aware of its general shape. So notice that it goes through the origin just here, and it does have rotational symmetry. So that if you rotated this section of the graph 180 degrees about the origin, it would generate this section down here. You don't need to remember what all cubic graphs look like, just what y equals x cubed has the general shape of. That can be quite useful. Question 4. Which one of these is a unit of density? Circle your answer. Now, the formula for density is a formula that you do need to know in the exam. Occasionally they will actually provide it in the question, but you do need to know it because it's not guaranteed. Now, density is equal to mass divided by volume. Because we know the formula, we will know the form that the units will take. Now, mass can be measured in kilograms, and kilograms is the standard unit of mass, particularly in physics. If you're asked about mass, you would measure it in kilograms. Volume standard unit is the meter cubed, and that's the standard unit that you would use in physics. Now, bear in mind that in maths, we're not just constricted to using the standard units. We can also use grams for mass, and we can use centimeters cubed, or we could use millimeters cubed. The main point is that the relation between the units must be some sort of mass to some sort of volume. Now, because it's mass divided by volume, there must be a forward slash effectively between the mass measurement and the volume measurement. And if we look here, we've got mass, which is measured in kilograms, and a volume which is measured in meters cubed, and these two are in the correct relation as shown by this formula below. So we know that kilogram per meter cubed would be the correct format. Kilogram per meter squared, if we were examining that, would be mass per unit area. Meter squared would be area. This one would be area per kilogram, so meter squared per kilogram, and this one would be volume per kilogram. So that's the formula written the wrong way round. The other formula you've just got to make sure that you know is the formula for pressure, which is force over area. It can also work both ways. So if you're given the units at the end of an answer, you can often figure out what the formula was that actually you would use to calculate it. So if I was given a question where I had something in kilograms and something in meters cubed, and I for whatever reason had forgotten what the formula for density was, but at the end of the question, because they frequently write the correct units for you, that have said given your answer in kilogram per meter cubed, I could have reverse engineered that and said that it must be mass divided by volume. So often paying attention to the units tells you what the actual original formula is. In this case, kilogram per meter cubed. Question 5. Solve. 4 3x minus 2 equals 2x minus 5. Now, solving just means that you've got to get the letter on its own in the singular, as in x equals. So it's really a question of rearrangement. First thing to do here is expand the brackets. So you'd multiply 4 by the 3x to get 12x, and 4 by the negative 2 to get negative 8. That of course is still equal to 2x minus 5. Now at this stage we've still got x appearing on both sides of the equation, and we want x on one side, and we want anything that does not contain x, as in the numbers, on the other side. Now with this type of problem I would usually look at which side's got the most x's on it. There's no rule that says you've got to put x on either side, but I generally try to keep the x values positive. So I notice that the left hand side has actually got more x's on that side. There are 12 of them versus 2x on this side. So if I subtract 2x, I will have 10x on this side. But I've still got to get rid of this negative 8 because that means I want the numbers on the right hand side. To get rid of a negative 8, I need to add 8, and negative 5 plus 8 equals 3. So 10x equals 3. All that remains now is to get x in the singular, so we divide by 10 to give x equals 3 over 10. Now 3 over 10 is perfectly acceptable as an answer. There's often a temptation at GCSE to think that every answer you get for a solution has to be written as a decimal, and that's not the case. You could write this as decimal format if you wanted. You could say 0.3, but there's nothing wrong in giving a fraction as your answer. So don't always assume that every equation that you do and solve, particularly on a higher paper, is always going to be some sort of neat decimal or whole number answer. It's not always the case. So 3/10 or 0.3 would be more than acceptable. Question 6. The graph shows information about prisms with the same volume. So we have a graph here with length measured in centimetres and area of cross-section measured in centimetres squared. The main point is that the prisms all have the same volume. Now we're asked here to give one example to show the volume is 24 centimetres cubed. Now one thing that you've got to be able to recognise, certainly in maths and definitely also in physics if you're doing that at GCSE, is different types of graphs that show proportional relationships. Now this graph here is a classical inverse proportion graph. I would know that the length L is inversely proportional to the area of the cross section here just by the shape of this graph. Now an inverse proportion relationship of this sort can be very easily verified by picking any particular coordinate on it and showing that they always equal the same constant value. Now you might notice that there are different points on this graph where the curve actually goes through integer coordinates. So for instance this point here is 212 and 2 times 12 is 24. If we look at this point here, 3 8s are 24, 4 6 is a 24, and then it sort of reverses direction because it's got a symmetry to it, this graph in y equals x. And we've got 6 times 4 is 24, 8 times 3 is 24, 12 times 2 is 24. Of course, if the graph was extended, you'd eventually end up at 24, 1, which is 24 when multiplied together. Now, if we look at that type of proportion, this is where it comes from. Now, we know that when we're dealing with volumes of prisms, that the volume is equal to the area of the cross-section times the length. So if we let the volume be V, the area be A, and the length be L, we can say V equals A times L. If we make L the subject, you would divide by A, so that would mean L would equal V over A, and that now matches the way this graph has been presented. The y-axis, if you like, so the vertical axis, is always effectively the subject of your formula, so in this case it will be L, which equals V over A. Now, V was a constant in this particular question, so V doesn't actually contribute to the relationship between L and A. The real proportional statement is that L is inversely proportional to A, which is shown by this here. Now, because the value of V was a constant, you can see that if you did L times A, as is illustrated here, and that's what we were doing with all of these coordinates, it will always be equal to the same value. So when they say give one example to show the volume is 24 centimeters cubed, all we needed to do was pick any particular coordinate on this particular curve and show that the product of the two ordinates, the x and the y, was equal to 24. And that's how you would verify an inverse proportion. Now, you do also have to recognize direct proportion as well. Direct proportion is just a straight line through the origin. And if they'd chosen to plot a graph, say, of volume against area for a prism, you would have seen a straight line. But because it was length against area, area itself is in the denominator of the formula, which meant it was going to have an inverse relation. Anything on the numerator will have a directly proportional relation, whereas anything on the denominator will be inverse. So you know that if you plot L against A, you're going to get this curved graph here, which we call a reciprocal graph. So that's the main thing just to observe with inverse proportion. But the actual mark simply comes from this bit here. So 6 times 4 equals 24 would get you the marks. 6b. The diagram shows a prism with volume 24 centimeters cubed. The height of the triangular cross section is h. Work out the height h. Now notice we've got the length of the prism here, which is 5 centimeters, and the base of the triangle here, which is 6 centimeters, and the perpendicular height, which is h. Now all prisms have the same cross section, so if you wanted to imagine what shape you would classify as a prism, it would be a two-dimensional shape projected into a third dimension. It would mean that if I cut this in the direction parallel to its cross section, I would always get the same triangle. So you can imagine this tent shape. If I kept cutting it across here or there, I would always chop it into sections that were basically the same triangle, and that's the case for any type of prism. The general formula to get the volume of a prism is volume equals the cross-sectional area times the length. Now we actually already know the volume here. It's just a component of one of the area calculations that we actually need to work out. The area, of course, is a triangle, which is a half base times height times the length equals 24. We know that the base is 6 and we know that the length is 5, so all we need to do is substitute those into the formula. A half times 6 times h times 5 equals 24. If we collect these together, 6 times a half is just 3, times by 5 is 15. So 15h would equal 24, divide by 15, so h equals 24 over 15, which is 1.6. So the perpendicular height there was 1.6 centimeters. Question 7. Describe fully the single transformation that maps triangle A to triangle B. Now there are 4 types of transformation that you have to be aware of at GCSE, and you've also got to be able to describe them from just visualizing what shapes you have available. Now one of them is translation. Now all that would happen in a translation is that the shape would move position. The shape would not change size, and it would not change orientation either in terms of what sort of direction it was facing. Now you can see here that A and B are different sizes, so there's no way that this can be a translation. The other types of transformation are maybe a rotation, which would not change the size of the shape, but it would change the direction it was facing. So again, it's not a rotation because it's changed size. The final one that we would also reject would be a reflection. Now you can see with triangles A and B that they're actually facing in exactly the same directions. With a reflection, that would not be the case. If you imagine your left hand and your right hand and you put them next to each other, you can see that although they are the same, they actually have opposite projections of where each object, each finger or thumb actually is lying. And if you had a reflection here, you would see that clearly with the triangle. The correct transformation that we're dealing with here is an enlargement. Now, once you've decided it's an enlargement, you need to describe what the scale factor of the enlargement is and where the centre of the enlargement is. Both of these are actually quite easy to obtain from the diagram. Now, always pay attention which direction they've asked you to describe the actual enlargement. Now, this was going from A to B. Now, just because B has got smaller, that doesn't mean it's going to be negative. So that's one thing just to note when you're dealing with enlargements. The way to find out what the actual scale factor is to pick 2 corresponding sides on each of the triangles. Now notice on triangle B, that length is 2 and that length is 6, and that's basically the same side for each triangle. A scale factor is the side you're going to divided by the side you came from. So effectively 2 divided by 6. 2 there divided by the 6 there. 2 over 6 is just a third. So you know that the scale factor is a third. The next piece of information we need is where is the centre of the enlargement. Now in the exam, all you need to do is get a ruler and line up each of the points on each of the triangles and join them together. So this point would line up with this point, that point lines up with that one, and that one lines up with that one. And find the point of intersection of those 3 lines. That point of intersection is the centre of the enlargement, which we can see here is 5, 1. So the full 3 marks come from 1 enlargement, scale factor a third, 2 marks, centre 5, 1, and that's your third mark. So that's what you need to say there. So it can get smaller, the shape, but that just means it's a fractional enlargement. So just bear that in mind if you are practicing these enlargements and you encounter ones where you've got negative scale factors. So smaller doesn't mean negative, it can just be a fraction that's less than 1. Question 8. The table shows information about the distances walked by 120 students on their way to school 1 week. So we have a table that shows distances x miles and frequency. We've also got the total there. We're asked to work out an estimate for the mean distance. Now, this particular type of table is called a grouped frequency table, and that could be recognised by the fact that you don't actually know the true distances that anyone actually travelled. You only know how many people are within each interval. We know that 20 people walk between 0 and 5 miles. 48 people walk between 5 and 10 miles, etc. Now, there are lots of questions that can actually stem from this table. One of them is to be asked to estimate the mean. You could also be asked about cumulative frequency, and you can also be asked about histograms. So just bear that in mind with these tables. So there's lots of questions that stem from it. We're going to have to estimate the mean because we don't know the exact distances that anyone travelled. Now, a mean is just the sum of all the values divided by the total frequency. So what we've got to do for the estimate is take a typical value for each of the intervals that we can let each individual person actually be. The sensible value would be to take the midpoint. So the third column that you initially fill out is for midpoints. The midpoint of each of these 4 rows, 2.5, 7.5, 12.5 and 17.5, will then be used in our calculation. If you want to find a midpoint, because occasionally they can give you numbers here that might not be that obvious what the midpoint actually is. Now all you've got to do to get a midpoint is actually add the 2 values at either end of the interval together and then divide by 2. For instance, 15 plus 20 is 35, divided by 2 is 17.5. So just in case the interval values are awkward to visualise what they actually are, to get the midpoint, just add them up and divide by 2. Now, the 2.5 here was representative of a single person, but there are 20 people in this interval, so the 4th column here is your midpoint times your frequency. So we multiply each frequency by the midpoint for all 4 of these rows. So 20 times 2.5 equals 50, 48 times 7.5 is 360, 30 times 12.5 is 375, and 22 times 17.5 is 385. We then sum these values here, so 50 plus 360 plus 375 plus 385 to get 1170. This represents the total estimated distance that all of the students travelled. But to get the mean, we then need to divide by the total number of students. The total number is already provided to us, it's 120. So 1170 divided by 120 equals 9.75 miles. A common error in this question is just to divide by the number of rows here, so as in divide by 4. But that's not what the mean is. The mean is division by the total frequency, so everyone there. Now, bear in mind that they might vary this question. The midpoint question, which is this one, to calculate the mean, has been a very common question in GCSEs for many years now, but you might have been asked to estimate the largest distance that was travelled by each student. So in that case, you might have decided to take the upper values as a typical value for each interval, or you might have been asked to estimate the lowest mean distance that everyone travelled. In that case, you would have took the lower values. So the midpoint is just taken as a typical point, but there's no guarantee, of course, that that's actually correct. Also note with this type of table that you cannot calculate the mode, the median, the mean, or the range with any degree of accuracy. All of those would have to be estimated. So it will always be an estimate if they ask you to calculate one of those different factors. Another thing to note, when you calculate a mean, say you had worked all this out, and supposing I'd calculated a mean of 25. Now I could very quickly check the original data and I would realise that I'd gone wrong straight away. Your mean, even if you estimate it, can never be outside the range of the values that you use to calculate it. So if we look at the intervals here, the lowest potential value was 0 and the highest potential value was 20. So the mean would have to lie somewhere between 0 and 20. So if I'd got 25, I would know that I must have gone wrong somewhere. Or hypothetically, although it wouldn't necessarily be possible, if I'd got, say, -2, which you'd never have got in this question, I'd know that would be wrong because I know the mean had to be between 0 and 20. It's always worth, with any maths question, just checking or looking back, does my answer look plausible? Because sometimes you can just process the numbers and forget about the context. But in this case, 9.75 is the correct estimate for the mean. It's within 0 and 20, so I'd already know that I'd got it right. Question 9. Work out the size of angle X. First thing to note here is that we have a right angled triangle and we need to find an angle, and we know two sides already. On a higher paper, you must become efficient at diagnosing what kind of triangle you're dealing with. Now, if you've got a right angled triangle, it's very likely that the maths required to deal with the information with the triangle is going to be Pythagoras or SOHCAHTOA trigonometry. If you're dealing with a non-right angled triangle, then you might well need the sine rule or the cosine rule or the area formula. So always ask yourself that question when you are dealing with triangles and you need to process the information. We've got a right angled triangle here and it has angle involvement, so that means it's got to be SOHCAHTOA. We label it with respect to the angle X here, so this side is the opposite and this side is the adjacent. Remember that the opposite side, this one, never touches the angle in question, so you always know where that's going to be. We use SOHCAHTOA to figure out which trig function we actually need to use. O and A, TOA means tan. So the first thing to write is that tan of X is equal to opposite over adjacent, O over A. Substitute for O and A, so it's tan X is equal to 3 over 7. And now we need to find out what X is itself. So you need the inverse of tan this time. So X will be inverse tan of 3/7. On the calculator, this is often a second function. So if you're using a Casio calculator, you'll need to press Shift and tan and then 3/7 to get your answer. Just as a side note, when you're dealing with trigonometry, there is no such thing as divide by tan or divide by sin or divide by cos. That is meaningless. To get rid of a sin, a cos or a tan, you must do the inverse operation. In this case, we get 23.2 degrees. Question 10. Work out the next term of this quadratic sequence. Now, in a quadratic sequence, the second difference is always constant. So when we're working out the next term, if we start by finding the first difference, so 5 to 8 is plus 3, 8 to 14 plus 6, 14 to 23 plus 9, we can see that the difference of the differences, or second difference as you might call it, 3 to 6 is plus 3, 6 to 9 is plus 3, so 9 will be plus 3 to get plus 12, and if we do 23 add 12, we will get 35, which is the correct next term in the sequence. For a higher paper, you are also expected to calculate the nth term of a quadratic sequence, but if it's not a question involving that particular problem, you need to be able to recognize them. So always look for the second difference. If the second difference is constant, then it is a quadratic sequence. Differences are only ever going to be additions or subtractions. So if you've got multiplication or divide involved in this, then it's not a quadratic sequence. It must be plus, 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 or minus, minus, minus. In this case, the second difference was plus 3, so therefore it's a quadratic, and we just use that to find the fifth term in this sequence, which is 35. Question 11. Circle the expression that is equivalent to 3x squared over 6x squared plus 3. Now we have an algebraic fraction here, and the best way to simplify an algebraic fraction is to make sure that both the numerator and denominator are fully factorised. Now there's only a single term in the numerator, so the numerator is fully factorised. If we look at the denominator, however, that is not fully factorised because it's still the sum of two terms which actually share a common factor. So the first thing to do is factorise it. All you can do in the denominator is take out a factor of 3. So when you do, you would get 3 brackets 2x squared plus 1. You can now see that a common factor of 3 is shared between both numerator and denominator. shown here as both of them being crossed out to show that they're both cancelled out. All you'd be left with then is x squared over 2x squared plus 1, and that's as far as the cancellation could actually go. It could be written in different ways if they wanted to, but none of them are actually done in the correct way. So x squared over 2x squared plus 1 is the correct answer. Question 12. The table shows information about the UK and Germany. So we have a two-way table here where we have UK and Germany, and we have the population and area in square miles of each of those countries. The population density is equal to the population divided by the area. Compare the population densities of the UK and Germany. All we need to do is substitute the relevant values into this formula for both the UK and Germany, and then check which value is larger or smaller than the other. Now we can see that Germany has a larger population and a larger area than the UK, but does that mean that its population density is larger or smaller? Well, if we substitute the values in for the UK, the population density is 64 million divided by 95,000 square miles. Because it was a comparison problem, there's no point in just writing this number to as many dp as the calculator shows. 674 as a rounded figure is more than is required for this problem. We then do the same for Germany, 82 million divided by 140,000, and for that we get an answer of 586. So what you can see here is that the population density of the UK is greater than that of Germany. So that would be your final statement there. That's why it's for 3 marks, because you've got to make that statement there. The population density of the UK is greater. So all that means is that for any particular area, there will be more people on average in the UK than there would be in Germany. Despite it having a larger population, its area is proportionally larger than the UK's, such that the number of people per area is more dilute, if you like. So the UK has a greater population density. Question 13. Two straight lines intersect at point P. Circle the coordinates of P. We have two lines here, y equals 3x and y equals -1. So P's coordinates are here, and we've got to figure out what they are. Now, every coordinate can be written as a pair, x, y. Now, we actually already know the coordinate of y because P lies on the line y equals -1. Every single coordinate on the line y equals -1 will have y equals -1 as its y value. So we already know that y equals -1 must be one of the values. All we need to do is determine the x value that goes with it. Now we do that by looking at y equals 3x. Now if y is equal to -1 on that line, then if we substitute y equal to -1 into y equals 3x, we can rearrange and solve for x. So -1 equals 3x, which means that x would have to equal -1/3 just by dividing by 3. So the correct answer would be -1/3, -1, as shown there. Question 14. A ball is thrown from a height of 15 meters. It bounces to height h1, then to height h2 as shown in this not drawn accurately diagram. h1 is 3/4 of the original height. Jack expects h2 to be 3/4 of h1. Work out the value of h2 that he expects. Now, this question is about compound decay, and all that means is that you are applying a multiplier successively to an original value. It's the same as what you might consider for compound interest when you put money in a bank account. The start value is 15. We're told that h1 will be 3/4 of 15. 3/4 is therefore the multiplier applied to 15. Because Jack expects h2 to be 3/4 of h1, we then have to multiply by 3/4 again. So effectively, you are taking 15 and multiplying it by 3/4 times 3/4. 3/4 of course is 0.75, so you've got the option of changing it to a decimal if you want to, but you are effectively squaring it. So the overall answer can be immediately obtained by doing 15 times 0.75 squared. So Jack would expect h2 to be 8.4375. h1 is just shown here individually, but technically for the answer all you really needed to do was this bit here. According to this model, you could infinitely multiply by 0.75, so the ball mathematically would never actually bounce to zero height. It would always have some sort of height that it bounced or rebounded to. But in reality, of course, it's always going to lose its energy, and you'd end up with a h equal to 0 at some point in the future. But 8.4375 is the answer in this question. Question 14b. In fact, h2 is 2/3 of h1. How does this affect your answer to part A? Tick a box. Okay, so it's either higher than expected or lower than expected. What's really going on here is you're comparing multipliers. Now, h1 would be found by taking 15 and multiplying it by 0.75 or 3/4 as we did previously. But then to get h2, rather than multiplying by another 3/4, you would actually multiply by 2/3 this time. When you do that, you find that 2/3 times 3/4 times 15 is actually 7.5. If we compare that to the answer in part A, we got 8.4375. So we can see that the ball actually bounces to a height that's lower than expected. So that's why we tick this box. In general, you could have actually answered that question by simply comparing 2/3 versus 3/4, because that was the only thing that determined why the value became less. 2/3 is less than 3/4. If you thought of it as a decimal, 2/3 is 0.6666 recurring, 3/4 is 0.75. So it was always going to multiply to give a lower value. So as long as we've shown evidence that the multiplier, or the absolute value as we've got in this case, is less than what it was before, then that's sufficient evidence to support our answer of the ball bouncing lower than expected. Question 15. Mirek invests £6,000 at a compound interest rate of 1.5% per year. He wants to earn more than £1,000 interest. Work out the least time in whole years that this will take. Now, before we begin to calculate that, let's just look at the general formula that we use to calculate the amount of money in a bank account after n years at R% compound interest. Now, Pn tells you the amount you've got in your bank account after n years. P0 is the initial amount invested, which would be 6,000. R is the percentage rate, 1.5, and n there is the number of years. So when we are calculating Pn, it would be 6,000, 1.5 for R, and then n would be whatever year you chose to pick. Now we're trying to figure out how long it takes him to gain more than £1,000 in interest. And that would actually mean that in his bank account, it would be the first year where he had more than £7,000 in his bank account. So we really need to use trial and improvement to figure out how long that actually takes. Now, in this first example, if we try 10 years, we would have 6,000 times 1 plus 1.5 over 100 to the power of 10, gives us 6,963. So you might trial and improve with a few of them. You might have tried 3-4 years, and you quickly realise that it's quite far away. So we go to 10 here, and we can see that it's close, but not enough. So we try 11 years, and you can see this time that when n is 11, we get 7,067. So we know now that that must have been the first year where the amount gained in the account was above £1,000. So by the end of the 11th year, he's actually got 1,067.69 gained in interest. So it takes 11 full years for that actually to happen. Question 16a. Factorise fully 9y cubed minus 6y. This will be a single bracket factorisation, and all you have to do is figure out what term goes outside of the bracket. So that's the common factor to 9y cubed and negative 6y. So in order, start with the numbers. You can see that 9 and 6 both have a factor of 3, and y cubed and y both have a factor of y. So you can take out 3y from both of them, then open bracket. 3y would need to be multiplied by 3y squared to return it back to 9y cubed, and 3y would have to be multiplied by negative 2 to get it back to negative 6y. So that is the final answer just there. Question 16b. Factorise 3x squared minus 22x plus 7. Now with this question, it's going to be two brackets. You can tell that because you've got an x squared and a constant with it as well. You don't always need the middle x value here to have two brackets, but in this case it has the x squared and the constant, so it's definitely two brackets. The other complication is that you've actually got a number in front of the x squared that isn't 1. Now, it will still be the same type of procedure as you would do if you just had 1x squared here effectively, but it's more complicated because one of the factors is going to be multiplied by 3 in this case. Now, to factorise it as a general method, start by writing a set of brackets, so a pair of brackets, and just write 3x in front of each one of them. So you would start with two brackets, 3x at the front, 3x at the front of both of them. Of course, you know it's not going to be 3x and 3x because you'd get 9x squared, but it will take care of that in a minute. The next thing to do is multiply the first number in front of the x squared, so the 3, by the lone constant, 3 times 7, which equals 21. Now you need to find a factor pairing of 21 that adds to make negative 22. Now both of them have got to be negative here, and the factor pair that works are negative 1 and negative 21, because if you do negative times negative you get positive, and negative 1 plus negative 21 equals negative 22. So you put negative 1 and negative 21 in either order into the brackets. You then inspect the brackets to check if any common factor can actually be taken out to reduce them by. Well, 3x minus 1, they don't share any factor other than 1, so that gets left as it is. But 3x minus 21 has a factor of 3, which you then divide by. You don't take it out, you just get rid of it, because you've got to restore the term in the brackets back to the correct size of value. In this case, you've got 3x times x now to make the 3x squared. When you divide these two by 3, you end up with x minus 7, and it's 3x minus 1, x minus 7, which is your answer. Now you can do this just by trial and improvement. You try and figure out a factor pairing where one of them will be times by 3, and you could get it to equal negative 22 when they were both added together. But sometimes it can be actually quite difficult, particularly if the number in front of the x squared has a lot of factors, so say something like 12, and the constant term has a lot of factors, so say something like 36 or 60. It can take a long time to deduce which factor pairing would work. So this method outlined here can be used as a generalized approach so that you can factorize it in good time. So 3x minus 1, x minus 7 is the correct answer. Question 17. Work out the area of the parallelogram. The general area of a parallelogram is found by multiplying the base by the perpendicular height. Now we do have a base length here of 16 centimeters, but the 12 is not the perpendicular height. The perpendicular height would have to be at 90 degrees to this 16. So we've got to find that perpendicular height to begin with. So what we can think of is a right angle triangle that can be formed by using the 12 centimeter side as a hypotenuse and 72 degrees as one of the angles in this particular triangle. So effectively we're drawing a perpendicular line from this corner down to the base here. So it's this right angle triangle that we're focusing on. Now that right angle triangle requires SOHCAHTOA to figure out what this perpendicular height is here. So since we're using SOHCAHTOA, we would need to label the triangle up. Now notice that although I've called that value h there, that is actually the opposite side to the 72 degree. The 12 is the hypotenuse, so we've got the opposite and the hypotenuse. So that's why from SOH in SOHCAHTOA we're going to use sine. So sine 72 must equal opposite over hypotenuse, h over 12, and h, which is what we require, we make that the subject. If you multiply by 12, 12 sine 72 will equal h. You can write it like that, and you can also type it like that in the calculator. You don't need to put a multiplication symbol in between a number and the trig of another value. The calculator will understand that. Now I'd leave it like that. There's no point rounding that because it's not even our final answer. Our real answer was to find the area. The area is the base times the perpendicular height. The base is 16. The perpendicular height is 12 sine 72. We multiply those together and we get 182.6 centimeters squared. So that will be your answer. Question 18a. Which of these represents the shaded region? Circle your answer. Now there are several symbols associated with Venn diagrams which you need to be aware of in order to answer this question. The first of them is this Greek letter psi, which is written here. Now that's the symbol enlarged just there. All that means is everything that's contained within the Venn diagram. In most GCSE questions it's not really relevant. You can just think of it as the total number of objects. Now we've also got an apostrophe style symbol here. So this actually means B complement, and that means not B. So whatever it is, if it's got a apostrophe style symbol, it means not whatever preceded it. We've also got this N-like symbol, which stands for intersection. Now that means A and not B, and when you've got an intersection, it must be both at the same time. That's in contrast to the U shape, which stands for union, and this would be A or not B. So this doesn't have the requirement that they both have to be at the same time. It's an either or type of statement. It also helps sometimes to just draw a bit of a sketch to show what each of these particular symbols actually mean. Now A just refers to the A circle, so it's the A circle shaded in its entirety. B complement or not B is just everything outside of the B circle. A or not B is individually shaded as A, fully shaded, and then the rest of which is not B, so that's shown there. But the actual answer to this problem is A and not B, which at the same time means the objects must be in A but not in B, and that's shown on the diagram here. Question 18b, which of these represents the shaded regions? Circle your answer. Now in continuation with what the first question asked, it's also worth just noting what each of these particular notations refer to in shaded areas. Now you'll notice that a couple of them have actually got brackets around them, so they mean the same collectivization of terms as they would in any other form of algebra. So if we look at this second one here, this is A and B, but then you've got the complement, as in not all of what's preceded it. Now A and B normally would actually refer to the overlap part in the middle, but because it's not that, it's really referring to everything else, so that's what that would look like. We have another intersection here. This is not A and B, so that refers to this section here, so it's in B but it's also not in A. Then we've got a union, so this is the either or version. Not A, so you'd shade everything that was outside the A circle, or it could not be in B, so you'd shade everything outside of the B circle. So you do those individually when you've got the union there, but they must satisfy both at the same time when you've got the N intersection shape. That just leaves us with the correct answer, which is A or B complement. Now A or B would normally refer to the full circle A shaded and the full circle B shaded, but it's complement, so it means not that or the opposite of it. Hence you would shade everything outside of the A and B circles. This means the correct answer is actually the first option there. Question 19. The length of a rectangle is 5 times the width. The area of the rectangle is 1620 centimeters squared. Work out the width of the rectangle. Now this first sentence here, 5 times the width, is actually a ratio description. So you could actually say that the length to width ratio was 5 to 1. Now you might have been able to persist with that idea, 5 to 1, and then be able to deal with the problem. But in the next sentence they've actually brought in a numeric value, and that strongly suggests that you also need to bring in some algebra into your approach to solving this. So if you let the width just be x, then you can let the length be 5x. The area of a rectangle is length times width, which means 5x times x, and we know that this must be equal to 1620. So 5x squared equals 1620. Divide both sides by 5, so x squared equals 324, and then square root both sides to get the correct answer of x equals 18. So your width was 18 as defined previously. So some questions, just bear in mind, you can actually approach and solve purely using ratios and proportions, but as soon as they bring in an actual numeric quantity that would be required in the model, you should really use an algebra approach. In other words, let the variables themselves be a letter rather than just letting them be a proportion of sorts. Correct answer is 18. Question 20. A stone is thrown upwards with a speed of v meters per second. The stone reaches a maximum height of h meters. h is directly proportional to v squared. When v equals 10, h equals 5. Work out the maximum height reached when v equals 24. So the first thing to recognise is the type of proportion that you are dealing with, and to write down that proportional relationship. So this symbol here, which looks a bit like an alpha, is the symbol for a proportion. So h is directly proportional to v squared. When you're dealing with a direct proportion, the variable will effectively be on a numerator. There isn't really need for any fraction here, so just h proportion v squared. Now that relation is only true for multipliers when you're looking at this, and we really need an equation to find out the answer to this problem. You could do it with just proportion, but we'll stick to the actual equation approach. So to convert the proportion into an equation, you need an equal sign, but as soon as you've done that, you need to put a proportionality constant in front of the variable. So h is equal to kv squared. So the initial objective is, well, what's the value of k? Well, you've already got a pairing of values. You know that v equals 10 and h equals 5. So if you substitute those into your equation, 5 equals k times 10 squared, you can rearrange and solve for k. So 10 squared, of course, is 100, and if you divide by 100, you'd have k equals 5 over 100, or 0.05. So that means that your overall equation, which you can treat as a formula now, is h equals 0.05 v squared. So when they ask us to work out the maximum height h when v equals 24, all we've got to do is substitute it into the equation. 0.05 times 24 squared equals 28.8, and that is the answer to the question. Question 21a. Mira is using a graphical method to solve 2x squared minus 3x equals 0. She draws the graph of y equals 2x squared and a straight line graph on the same grid. Here is the graph of y equals 2x squared. So we have the characteristic quadratic positive shape there. Complete her method to solve 2x squared minus 3x equals 0. Now you have two ways that you can choose to solve an equation. One of them is to use algebra, and the other is to draw an accurate graph and use that to find your solutions. Algebra will typically be precise and that you'll get an exact value. Graphical methods are really down to the complexity of the graph that you're trying to sketch and how accurately you actually sketch it. Now you can actually rearrange an equation into an infinite many forms, and you can see here that 2x squared, which is what we've already got sketched here, features in this particular equation. Now when you are using an equation and solving it using a graph, you want to get the graph that they've already drawn for you, i.e. 2x squared, isolated. So that's what's happening here. So 2x squared minus 3x equals 0. You would add 3x to both sides, so you get 2x squared equals 3x. That means then, to find the solution of the original equation, you need to sketch y equals 3x. That's the straight line graph that she must have drawn in this problem. So you sketch the graph of y equals 3x. Remember, it's a linear graph. You only really need 2 points on it to sketch it properly, but that can be done quite readily here because it goes through the origin. If you remember, the gradient of it will be 3. So 1, 3, 2, 6, they will be on it. That would be sufficient. You could join those 2 points together to sketch that graph. Now the solution to the equation will be the intersection points. The origin, don't forget, is also an intersection point here. The graph would continue through the origin there. And the other point of intersection appears to be at x equals 1.5. So the intersection points are x equals 0 and x equals 3 over 2 or 1.5. Question 21b. Levi is solving 2x squared plus 5x equals 0. He uses this method. 2x squared plus 5x equals 0. Subtract 5x from both sides. So we get negative 5x on the right there. Then he divides both sides by x to get 2x equals negative 5. Then he divides both sides by 2 to get x equals negative 2.5. Evaluate his method and his answer. Now what you're dealing with here is a quadratic, and your standard approach to solving it should really be factorising it where possible. The mistake that he's actually made is to divide both sides by x. Now the problem with doing that is that you actually lose one of the solutions. X itself could actually be 0, and that's a valid solution. So when you are rearranging a quadratic or cubic or any particular polynomial, when you divide through by a value, you'd have to be sure that it was never equal to 0 for one of your solutions. Since this is an abstract question in the sense that we don't really know what this equation relates to in the real world, we have no reason to divide by x. So what we should really do is at this stage, right at the start, is factor out the x to get x to x plus 5. We then set this itself equal to 0, which presents two different solutions. One of them is that x itself equals 0, and the other is that 2x plus 5 equals 0, which would mean x would equal negative 5 over 2. You can see that in his method, he lost the x equals 0 solution, so his solution set was incomplete. For the marks, you can mention that you cannot divide by x at that stage, or that he's lost the solution, or the best way really is just to solve it properly and show that you get these two solutions given here. Question 22. The cross section of an earring is a semicircle, centre C, radius 25 millimeters. The earring is black and white. The shaded area is black. Okay, so we can see here that we've got a semicircle there of radius 25 millimeters, and we've also got this sector here, CBD. The sector BCD is white and has radius 12 millimeters. Also note the angle here is 150 degrees. Is more than 20% of the semicircle white? You must show your working. Now, ultimately, this is actually a numerical comparison problem, and you've got to think about how would you actually work out what percentage you did have, and how would you compare it to the statement. Now, a percentage is just a statement of proportion. 20% is just 0.2. And the question is the proportion of the white sector out of the entire semicircle greater than 0.2? So what we're really saying is the proportion greater than 0.2? So what we really need to do is figure out, well, how do you represent the proportion? Well, the proportion will be the small sector, this, BCD, divided by the entire semicircle. The area of a sector is given by the angle it subtends, which we know is 150 degrees, divided by 360, multiplied by pi r squared. So remember that the radius of the sector was 12 millimeters, so multiplied by 12 squared. And the area of a semicircle is just a half pi r squared, where r was equal to 25 for the larger semicircle shown there. Now we can be efficient here as well, because notice that if you were using a calculator, yes, you can just type all that in and get your answer, but the pi's are going to cancel out there, so they could actually be ignored in your calculation. But when you type the rest of the numbers in that fraction, you get 0.192. Well, the target statement was based upon 0.2. More than 20% meant that your answer had to be more than 0.2, and it clearly isn't. So the answer is no. You could actually say that this sector here actually occupied 19.2% of the overall semicircular area. So just remember that when you are trying to evaluate a question that's basically numeric comparison, try and think about what you'd actually use to compare your value against. So if they say it's greater than 50%, they're saying it's greater than a half or 0.5. So your target should be, how do I get that percentage? In this case, it's 19.2%, which is less than 20, so therefore no. Question 23. Here is some information about a tennis club. So we have members of a tennis club, frequency density, and age A given in years. Now, this is a histogram problem because we've got frequency density on the vertical axis. So in a histogram, one of the more important facts about it is that the area of each rectangle represents the frequency of the particular interval. So if I wanted to know how many people are between 0 and 20 years of age, it would be the area of that rectangle there. Between 20 and 30, it would be the area of this rectangle. But there's an immediate problem here, because you'll notice that the frequency density axis has no units on it. Now this is actually ever so slightly the more common type of histogram question encountered. You're more likely to be given a complete histogram more than be asked about drawing one. So here we've got the issue of labelling this axis for frequency density and figuring out what its actual increments are. So we have to look at the facts in the question. So there are 30 members with A less than 20. So that's quite helpful already, because that's effectively linked the area of this histogram first section with the value of 30. We know that the area of that must be 30. There are 12 members between 65 and 80 years, so an area of 12 must be represented over here, and there are no members that are over 80 years of age, so you know there'll be no rectangles to be drawn after the 80 there. We have to complete the histogram. So what we can do is we can add a scale to our histogram to begin with. So we've got each of the large squares here, and we can label it x, 2x, 3x, 4x, etc. Don't bother trying to label the smallest ones. You can do that, but you might as well just go up in 1, 2, 3, 4 and then recalibrate your scale once you know what your value of x is. Now, we did know that the area of this particular rectangle here had to be 30, but we also know its width here is equal to 20. So we can say 3x, which is the length, multiplied by 20 must equal 30. So 3 times 20 is 60, 60x equals 30, divide by 60, and x equals 0.5. So we now know that the histogram is actually going up in 0.5s. We can also now complete the final rectangle. Now, a formula that you must remember for histograms is that frequency density equals frequency over class width. And we've got a frequency for the last rectangle of 12, and we know the class width is actually 15 because it's 65 to 80, that's a difference of 15. So the frequency density will be 12 divided by 15, which is 0.8. Now remember, if this is 0.5, it means that the micro squares, if you like, are actually going up in 0.1s. So 0.8 will actually fall at this height here, and you can complete the final rectangle shown in the histogram. The last thing to do is then actually correctly label the vertical frequency density axis. Here is the completed histogram to show the correctly labelled numeric axis with the correctly shown and shaded box to show the frequency of 12 at the end of the histogram. So if you'd done all that, you would get full marks in the question. Question 23b. Work out the total numbers of members at the club. Now we know from before that the area of the histogram is equal to the frequency and therefore the total number of members. Also note for 23 part A, we do actually have to complete the vertical frequency density axis numerically, but for the moment you've actually got the option. You could leave it in terms of x if you want, since you know x is 0.5, and then label up after once we've completed the other part of the question. Either way you're going to get the same answer. So because we're going up in single values of x, we can quite easily write down what the areas of each of these rectangles actually are. Some of them we already know directly. So for instance, we already know that this one's 30, and we know that this last rectangle is equal to 12, so we can actually leave them out if you like. So overall, we've got 30 plus 9x times 10. So of course this rectangle here was 9x and it had a width of 10, 20 to 30. Plus, note that's 7.2x just there, that's not on 7, it's one square up, so that will be 7.2x, and then that will be multiplied by 10. Then we have this rectangle, which is 4x, which will be multiplied by 25, and then we can add all those together, and because we already know what x is, we can substitute that into our expression to get the overall area. So of course 9 times 10 is 90, 7.2 times 10 is 72, 4 times 25 is 100, and then we've also got the additional 12 there. 90x plus 72x plus 100x is 262x, and 30 plus 12 is 42. We can now substitute the x in, which will be 0.5, and when you process that, you've effectively got 131 plus 42, which is 173. Now if you'd wanted to and you'd already labelled it, which you most likely would do if you were doing it in order, you would also have just multiplied, say, this first rectangle by 20 times 1.5, this one by 10 and 4.5 because you'd have already labelled the axes, but either way you're still going to get the right answer, which is 173 people in the club. Question 24. Beth ran a 200-metre race. Here is a graph of the first 8 seconds of her race. She completed the race at a constant speed of 9 metres per second. So we have a speed time graph for Beth. The speed is measured in metres per second and the time in seconds. Now always remember with the speed time graph that the area underneath the graph, the line or the curve, will be the distance travelled, and the gradient, although not relevant to this part of the question, is equal to acceleration. Amy completed the race in 27 seconds. Did Beth finish before Amy? You must show your working. Well, first of all, we know that Beth finished the race at a constant speed of 9 metres per second. So if you were to add this to the diagram, there'd be a horizontal line going across here, which would end once the area underneath this particular diagonal and straight line, which forms a trapezium, was equal to 200. Now, if we can find out when the area does become equal to 200, we can then figure out how long it took Beth to actually complete the race, and then compare it to Amy's 27 seconds. So effectively what we've got here is this shape. Now you can look at it as a trapezium, or if you wanted to, you can just split it up into a triangle, a right angle triangle, and a rectangle. Now the base of the triangle will be 8 and the height will be 9, so that's shown there as 8 and 9. And we'll call the unknown width of the rectangle t. So t effectively runs from 8 to an unknown point on the time axis, and the height or length of the rectangle will also be 9. So we can now write an equation, because we know that the area of the triangle plus rectangle must equal 200. So a half base times height is the area for a triangle, so a half times 8 times 9, plus the area of the rectangle, which is just length times width, 9t, must equal 200. Half times 8 times 9 is just 36, plus 9t equals 200. Subtract 36, so we get 9t equals 164, and divide by 9. So to 1dp it's 18.2. Now t, remember, is not how long it took Beth to complete the race, because t actually only started at 8. So we also have to add 8 onto that to show that Beth took 26.2 seconds to complete the race. Since 26.2 is less than 27, we can say that Beth won the race. So the answer is yes. Question 25. The dimensions of a rectangular floor are to the nearest 0.1 metres. So we have a rectangle here, 2.6 metres by 6.4 metres. A force of 345 newtons is applied to the floor. The force is to the nearest 5 newtons. We're given the formula here that pressure equals force over area. You might not be given that in the exam, so it's worth remembering it anyway. Work out the upper bound of the pressure. Give your answer to 4 significant figures. You must show your working. Now, the overall answer is going to be dependent upon this equation here. Now, if we are after the upper bound of the pressure, we need to be considering what the bounds will be for the force and the area. Now, you've got a numerator and a denominator. If you want the pressure to be the maximum, so the upper bound, then you want the numerator to be that also. So the numerator should always copy what you want overall. So if the pressure is maximum, the force should be maximum too. We want the upper bound for the force. But the denominator will be the opposite. The denominator is inversely related. So if you increase the area, you decrease the pressure. Well, we want the pressure to be maximum, which means we want the area to be minimum. You can think of this in the real world as more force on a smaller area is going to equal a larger pressure. It's the elephant's foot versus the stiletto. Now we've got to deal with how do we write the particular bounds. Now we're already directly given the level of accuracy here. It's the nearest 0.1. Now whenever you are given a degree of accuracy for your bounds, you must halve it. So 0.1 would be divided by 2 to give 0.05. Now this is the number that you would plus and minus respectively to each of the width and the length of the rectangle here. So you can see if you took it away, you would get 2.55, and if you added 0.05 you'd get 2.65. Same with the length, subtract 0.05 you would get 6.35, and add 0.05 you would get 6.45. Now we already know that we're only actually going to need one of these particular bounds for each one of them. For the force, we're told it's to the nearest 5 newtons, so following the same procedure, divide it by 2, so 2.5, and it will be 345 plus or minus 2.5, which would give you 342.5 or 347.5. Now we were told to get the upper bound for the pressure, so we said we needed the upper bound for the force, so that means we're going to be using 347.5. But we also said we needed the lower bound, or the minimum value for the area. Well, the minimum value for the area will be the lower bound products of the length and width. So we would have 2.55 times 6.35. When we multiply that, we get 21.46, etc. But the answer is required to 4 sig fig, so it's 21.46, which is your upper bound for the pressure. Now, we didn't discuss at the start of this, but make sure when you've got your bounds that you have checked that the bounds also match the units that they're measuring in. So you can see here 0.1 meters directly matched the lengths shown for the rectangle, and newtons, nearest 5 newtons, matched the force measured in newtons as well. You must make sure you convert either the bound accuracy or the lengths you're given, or widths, or whichever value you want to use, so that the bounds are consistent before you start using your plus and minus to find out the lowest and highest values. In the end, 21.46 is the correct answer. Question 26. ABCDE is a pentagon. Show that BCDE is a parallelogram. So note, first of all, we've actually got 4 of the sides are actually labelled with their respective vectors. So remember, vectors also have a direction, so you have to take note of the direction that these arrows are actually pointing in. If you go against the grain or against the arrow, then it swaps the sign of the components of the vector. So B to A would be plus A, but A to B would be negative A. Now, to show that BCDE is a parallelogram, we would have to show that it has 2 pairs of parallel vectors, which of course would be equal, but the pairings themselves are also not equal. So to explain, BE would have to equal CD, and ED would have to equal BC. But of course BE and BC have to be different as well to show that it is a parallelogram. So to begin with, we will find what the vector B to C is. Now remember, with vectors you can only go along routes that you know. Now a route that you know is ones where you've got the bold lettering. You can see that going from B to C, there's no direct pathway. So we go B to A to E, E to C. So BA plus AE plus EC. All of those are with the grain. So it will be A, add 2B, add B minus 2A, which equals 3B minus A. Now we'll find vector ED. Well, that's already given, but it's just against the grain of the vector, so it would be negative A plus 3B, or 3B minus A if you wanted to reverse it. So we've already shown that BC and ED are equal, so that means they're the same vector and they are parallel. Now for the vector B to E, well, B to E equals B to A plus A to E, which is A plus 2B. And the vector C to D, well, that equals C to E plus E to D. But both of those are against the grain of their vectors. So it would be negative B plus 2A for C to E, and minus A plus 3B for E to D. Combining those together, you get A plus 2B. So therefore BE equals CD. And we can also see directly that BC and BE are not equal. 3B minus A is not equal to A plus 2B. So the shape overall must be a parallelogram. So that concludes the proof. Question 27. Solve x over 4 minus 2x over x plus 2 equals 1 give your solutions to 2 decimal places. You must show your working. Now the fact that it says solutions should suggest to you that you're at the very least dealing with a quadratic, and to 2 decimal places also tells you that it will be the quadratic formula that you're going to be using. If you were factorising, it's very unlikely that you'd be giving any value to 2dp. You'd nearly always get integers or low level of decimal places in your numbers. So when they give you any kind of rounding like 3 sig fig, 2dp, 3dp, etc. for some sort of equation problem, it strongly hints the quadratic formula. Before we use the quadratic formula though, we've got to get this particular equation into the standard presentation of ax squared plus bx plus c equals 0, because the quadratic formula is based upon that arrangement. Now the first thing to do is get rid of these denominators, so we can instantly multiply through by 4 and also x plus 2. So every single term, 1, 2, 3 of them, will be multiplied through by 4x plus 2. For the first fraction here, if you multiply by 4, it cancels that out, but then you'd have an x plus 2 left. If you multiply this fraction by 4x plus 2, the x plus 2 cancels out with that one, but you'd also multiply it by 4, so you have negative 8x. The 1 though will be multiplied by both of them, and you not get any cancelling, so it will be 4x plus 2. Expand the brackets on both sides to get x squared plus 2x minus 8x equals 4x plus 8, and collect the terms on the positive x squared side so you can set your equation equal to 0. So we've got 2x minus 8x is minus 6x, and then we're minusing another 4x, so it will be minus 10x, then subtract 8. So when you use the quadratic formula, make sure it's equal to 0. You don't necessarily have to have the x squared term being positive, but it's just a standard way of presenting the quadratic. Now remember that a, b and c are the coefficients of a squared, x and the constant respectively. So a is 1, b is negative 10 and c is negative 8. Here's the quadratic formula which you must remember. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, b itself is negative 10, so negative b will be positive 10. Plus or minus b squared. Well, this part's always going to be positive here anyway, regardless of negative or positive. Negative 10 squared minus 4 times a, which is 1, times c, which is negative 8, all over 2 times 1. So equals 10 plus or minus the square root of 132 over 2. Now, you could just at this stage type all of that into your calculator to get one of your values. Remember, the only difference between each of the values is whether you have done addition here or subtraction. Either way, just go back on your calculator and swap the sign at this location so that you can generate both solutions. X equals 10.4 to 2dp and x equals negative 0.74 to 2dp.